Making Sense of the Periodic Table, Chem 103, Preparatory Chemistry at Ferris State University with Peter Belanda. Most elements react with oxygen to form oxygen-containing compounds called oxides. When oxides dissolve in water, the solution may be acidic or basic. The purpose of this experiment is to look for patterns in acidity and basicity of the oxides within the periodic table. For this experiment, we will need a series of solutions prepared by dissolving oxides of several elements in water. The elements and solutions we will examine are sodium in sodium hydroxide, antimony in antimony 5-oxide, arsenic in arsenic 3-oxide, phosphorus in diphosphorus pentoxide, chlorine in chloric acid, nitrogen in nitric acid, magnesium in magnesium hydroxide, sulfur in sulfuric acid, bismuth in bismuth 3-oxide. Well, we simulated this one. Bismuth oxides are insoluble in water. We also need a universal pH indicator solution to make color observations for spotting the trends. You will be asked to describe the colors you see when universal indicator is added to the oxide solutions. The color of the solution correlates with its relative acidity or basicity. Please use the color scales that follow. The basic universal indicator color interpretation scale has 4 colors: red for most acidic, orange for acidic, green for basic, and blue for most basic. If you get a little bit more ambitious, you can use an expanded universal indicator color interpretation scale, where if a color is somewhere between red and orange, but more orange than red, we would call it reddish orange. If the color was between orange and red, but more red than orange, we could call it orangish red. Likewise, if a color was between orange and green, it could be greenish orange or orangish green, depending on whether it was closer to orange or closer to green, and so on. Pay close attention to the actions taken in this video. Record your observations. As the video proceeds, questions will appear. Pause and rewind the video as needed to answer the questions using the corresponding lab submission form. Pause now and make sure that the correct Making Sense of the Periodic Table submission form is open in another browser tab. Notice that a wax pencil is used to build up a thick wax grid. What might that grid be used for? Sodium, Na. Magnesium, Mg. Nitrogen, N. Phosphorus, P. Arsenic, As. Antimony, Sb. Bismuth, Bi. Sulfur, S. Chlorine, Cl. Universal indicator. How many drops of indicator were placed on each square? What about the oxide solutions? Did you make that observation? Pause now if you need to record the colors obtained for each oxide. Question 1. Why was a thick wax line drawn on the clear film overlaying the periodic table? A. To easily see where to place the drops. B. To contain the drops so the oxides wouldn't mix. C. Both of these. Question 2. How many drops of each oxide were placed in the grid? A. 0. B. 1. C. 2. D. Oxide. What oxide? Question 3. How many drops of universal indicator were placed in each box on the grid? A. 0. B. 1. C. 2. Question 4. Describe the color of the sodium oxide solution after adding the universal indicator. Since color is open to interpretation, more than one correct response may be accepted. A. Red. B. Orangish red. C. Reddish orange. D. Orange. E. Greenish orange. F. Orangish green. G. Green. H. Bluish green. I. Greenish blue. J. Blue. Question 5. Describe the color of the magnesium oxide solution after adding the universal indicator. Question 6. Describe the color of the phosphorus oxide solution after adding the universal indicator. Question 7. Describe the color of the sulfur oxide solution after adding the universal indicator. Question 8. Describe the color of the chlorine oxide solution after adding the universal indicator. Question 9. Describe the color of the nitrogen oxide solution after adding the universal indicator. Question 10. Describe the color of the arsenic oxide solution after adding the universal indicator. Question 11. Describe the color of the antimony oxide solution after adding the universal indicator. Question 12. Describe the color of the bismuth oxide solution after adding the universal indicator. Question 13. Based on your observations, does the base character of oxides of elements increase or decrease from left to right in a period, a horizontal row? A. Base character increases from left to right. B. Base character decreases from left to right. C. There is no change in base character within a period. Question 14. Based on your observations, does the acid character of the oxides of elements increase or decrease from left to right in a period, a horizontal row? A. Acid character increases from left to right. B. Acid character decreases from left to right. C. There is no change in acid character within a period. Question 15. Based on your observations, does the acid character of oxides of elements increase or decrease from top to bottom in a group or family, a vertical column? A. Acid character increases from top to bottom. B. Acid character decreases from top to bottom. C. There is no change in acid character within a group. Question 16. Based on your observations, do oxides of metals dissolved in water form acidic or basic solutions? A. Oxides of metals form acidic solutions when dissolved in water. B. Oxides of metals form basic solutions when dissolved in water. Question 17. Based on your observations, do oxides of nonmetals dissolved in water form acidic or basic solutions? A. Oxides of nonmetals form acidic solutions when dissolved in water. B. Oxides of nonmetals form basic solutions when dissolved in water. Question 18. What might you predict for the behavior of the oxides of the metalloids, the in-between elements like aluminum and silicon? A. Oxides of metalloids would form acidic solutions when dissolved in water. B. Oxides of metalloids would form basic solutions when dissolved in water. C. Oxides of metalloids would form acidic or basic solutions depending on their position in the periodic table. This concludes today's laboratory assignment.